Episode 20, Inflation and the Early Universe. In the last episode, we discovered that Edwin Hubble had shown that the universe is expanding. Distant galaxies are moving away from us, and the farther away they are, the faster they appear to recede. It was one of the greatest scientific discoveries of the 20th century because it suggested something remarkable. Um, if the universe is expanding today, then in the past it must have been smaller. Go back far enough, and everything we can see around us today, every galaxy, every star, every atom, and every particle, must once have occupied an extraordinarily tiny region. At first, scientists imagined this expansion simply running backwards, like watching a film in reverse. Galaxies would move closer together, stars would merge, matter would become denser and hotter, until eventually the entire observable universe would be compressed into something unimaginably small. However, by the late 20th century, astronomers began to notice problems with this picture. One of the most puzzling observations involved the faint glow that fills the sky in every direction. This radiation, known as the cosmic microwave background, is thought to be the afterglow of the Big Bang itself. It was first detected accidentally in 1965 and has since been measured with extraordinary precision. What surprised scientists was that this glow has almost exactly the same temperature everywhere. No matter where they looked, the difference was only a tiny fraction of a degree. This presented a serious difficulty. Light travels at a finite speed, and there simply should not have been enough time for opposite sides of the young universe to exchange energy and settle to the same temperature. It was rather like finding two people on opposite sides of the world speaking exactly the same language despite never having had any contact with one another. There was another mystery. Measurements suggested that the geometry of the universe is astonishingly flat. If the universe had started out even slightly curved, that curvature should have grown over billions of years. By now, space should appear noticeably bent. Yet observations indicate that it is almost perfectly flat. It was as though someone had balanced a pencil upright on its point and discovered that it was still standing billions of years later. Physicists searched for an explanation, and in the early 1980s, they proposed a bold new idea called inflation. According to this theory, the universe underwent a brief but extraordinary period of expansion in its earliest moments. During this episode, space itself expanded at an incredible rate, far faster than anything we see today. Regions that had once been close enough to exchange energy and information were suddenly stretched apart to enormous distances. To understand this, imagine drawing two dots a millimeter apart on a balloon. As you inflate the balloon, the dots move farther apart, not because they are traveling across the surface, but because the surface itself is growing. Inflation suggests that something similar happened to the universe, although on a scale so vast that it defies imagination. People often say that the universe expanded faster than the speed of light. At first sight, this sounds impossible because Einstein taught us that nothing can travel faster than light. However, Einstein's limit applies to objects moving through space. Inflation concerns space itself expanding. The galaxies were not racing through space faster than light. Rather, the fabric of space between them was stretching. In Einstein's theory, there is nothing to prevent space itself from expanding at any rate whatsoever. This naturally leads to an even stranger question. What was the universe expanding into? Our everyday experience tells us that things expand into something. Smoke expands into air. A balloon expands into the room around it. Water spreads into an empty container. But according to our best theories, the universe was not expanding into pre-existing emptiness. Space itself was coming into existence and growing. There may not have been an outside at all. This is difficult to picture because our minds evolved to deal with ordinary objects inside ordinary space. We instinctively imagine the universe as a gigantic sphere floating in some larger emptiness. Yet, physics does not require such an emptiness to exist. There may simply be no meaning to the phrase outside the universe. A useful analogy is to imagine an ant living on the surface of a perfectly smooth globe. The ant can walk in any direction without ever finding an edge. It can continue indefinitely and eventually arrive back where it started. To the ant, the surface has no boundary. It is finite yet unbounded. Some physicists think our universe might be similar, except in three dimensions rather than two. Others believe the universe may be truly infinite. At present, we do not know. The question of time becomes even more fascinating. If inflation occurred at the very beginning of everything, then what happened before inflation? Was there a moment waiting for inflation to begin? Did time already exist? Many physicists would say that asking what happened before the Big Bang may be like asking what lies north of the North Pole. If time itself came into existence along with the universe, then there was no earlier moment. There was no cosmic clock ticking away in the background waiting for events to start. Inflation may not have happened within time. Instead, inflation may have been part of the process that brought time itself into existence. Scientists sometimes discuss unimaginably tiny intervals after the beginning of the universe. These periods are so short that they cannot be measured directly and are far beyond anything humans can experience. They do not suggest that time itself is made up of tiny chunks. Rather, they are simply the scales at which our present theories can still make meaningful predictions. Beyond those scales, our understanding begins to break down, and we do not yet possess a theory capable of describing what truly happened. Perhaps one day, a new theory will replace inflation. Perhaps it will explain why the universe appears flat, why distant regions have almost the same temperature, and why time seems to have begun when the universe itself began. For now, inflation remains one of the most successful explanations we have, but it is important to remember that science is always provisional. Every theory is accepted only until a better explanation comes along. And so we arrive at a profound and unsettling thought. If space can come into existence, if time itself can begin, and if the universe can expand without expanding into anything at all, then perhaps our everyday understanding of reality is only a tiny fragment of a much larger picture. In the next episode, we shall return to Albert Einstein's famous thought experiment and ask an extraordinary question. What would happen if you could ride alongside a beam of light? Would time stop? Would the universe flash past in an instant? Or is the very question impossible to answer? Thank you for watching and listening. If you've enjoyed traveling through time with me, please like and subscribe. And if the next episode is available, click on it now and let's continue the journey together.